Emily figured this out this morning. She had this, her idea was when you have two, and I've noticed most of you guys do this all the time, which is great. It's super visual. And if you're plotting your two solutions of, I'm just making something up. Let's just say this was a cosine problem, a sine problem, and let's say it was pi over 3. And it was a sine one, so we're at, this would be my root 3, here's my 1, my -1, my root 3, and 2. So whenever you plot these things, if you wind up with your two solutions that you find, or your answers that you get, if they're next to each other next to each other in each quadrant, whether it's quadrant 1 and 2 or quadrants 1 and 4, or however it works out, or even if it's those two or these two, or whatever, if your answers are next to each other, it's list out both of your parts, like pi over 3 plus 2 pi n. That will always look like that. If their two answers are next to each other, there will always be plus 2 pi n. Okay? You only have to worry about, and that's for sines or cosines. Okay? That's for sines or cosines. That'll always happen. All right? When it switches up, excuse me, when it switches up tangents, remember, tangent is positive in first and in third. And the way that tangent works, since you're using this reference angle, those two angles are always going to be the same. So if you get a tangent problem, your tangent will, if it's just one solution, or excuse me, if it's not a square, what do you have to take a square root for? If it's just a singular tangent, it's always going to be plus a pi n, because this is always 180 degrees away. Okay? When you get into whether it is sine, cosine, or tangent, you had a squared term. When you plot your graph out, you would wind up with 4 solutions. You always had positives and negatives, whether it was sines or cosines or tangents. This is the case then you would, if it was a 30 degree or a, where's Devin go? I thought he was here. There he is. All right, we lost you, Devin. We found you. No. If I'm at all 4, then if it's a 30 or if it is a 60, all you have to do is list out these first two plus pi n. If it is all 4 and it is a pi over 4, then it's a, if this was 45, I mean this is 90 degrees, 90 degrees, 90 degrees, 90 degrees. That's when you have your pi over 2. That's the only time that happens if you get all 4 45-degree angles. Okay? I think that's about as generic as I can make these. So as you're going through these, if I'm looking at the first 4, you had a root 3 cosecant, you had a 2 sine squared, you had a 3 secant squared, and a sine squared plus sine. Which of those 4 was the most pain in the butt? Oh, Colby, I'm sorry, you had a question. What do you got, bud? Sure. Good. Nice, nice. So on 10, when you have sine squared x plus sine of x is 0. This is the type, when you see a squared and a non-squared, you're going to want to factor something. Okay? It isn't traditional what times what's this to add together to get the tail. Since there's only 2 parts here, I can only do a GCF. So if I do that, I get sine squared x, sine of x times sine x plus 1 is 0. So now I can take both those 2 terms and set them both equal to 0. Sine of x equals 0, and sine of x plus 1 is 0. And then that means what angle has a sine of 0, what angle has a sine of -1. So whenever I have sines or cosines of 0s or 1s, I know I'm going to have to go to my quadrantals. Okay. So then I go ahead and plot. Here's 1, 0, 0, 1, negative 1, 0, 0, negative 1. Is sine my x or my y coordinate? My y coordinate. So where is sine 0? 0 and pi. So I have answers at 0 or pi. Those two are the same distance apart from one another, correct? So my answer would then be 0 plus pi n. Some people wrote pi n, that's fine too. Is that what you're going to say? That's fine. You okay, Devin? Okay. Spoiler alert. Good morning. And then where's sine at negative 1? Somewhere. Somewhere there. 3 pi over 2. Is that a high five? That was the best sounding high five ever. That was awesome. And then this one would have to go plus 2 pi n. Because there's just one of them, you have to keep going all the way around to get back to it. Okay. Is that helpful? Yeah. Usually quadrantals, people don't like them. I don't know why. Oh. Now the other one on this page here, I want to walk through number 9 because I like having the secant squareds and having to go through all that. So when I go to this one, you guys okay? Add 4, divide by 3. So we have secant squared. At this point, did you guys reciprocal it or did you take the square root first? Okay, you can do either one. It's perfectly fine. I would do the square roots first and then I would reciprocal everything. So I have secant of x is plus or minus 2 over root 3. And then I would reciprocal it. What's the reciprocal function of secant? Cosine, very good. So what angle has a cosine value of plus or minus root 3 over 2? So notice I'm going to be in all 4 quadrants. Root 3. Root 3 has the opposite angle of what? Excellent. Oh, but it's cosine. Sorry. I thought it was a sine problem. Cosine has the root 3 as its adjacent. So that's going to be a 30-degree angle. For some reason, I thought I was dealing with the sine problem. So thanks. I'm up pi over 6, up pi over 6, down pi over 6, down pi over 6. Great drawing, I know. Since I'm all 4 quadrants, I only have to list out 2 of them. Because it's pi over 6, I don't need to get all, I can't do a pi over 2 here. So it would be a pi over 6 plus pi n. And then this one on this side would be how much? Excellent. And there you are. Meh? Sure. Because this was a general solution. When you're dealing with general solution, you're trying to see how fast can you get back to the same to an answer. When you're looking for the when it says solve on the interval, that's when you list out all 4. General solutions, you're going to have something with an n in it because there's a letter n in general. Yes, ma'am. Two out of the, well, it depends on the angle. For 2 out of the 3 angles, yes. 45s, it was plus minus 45s, it'd be a pi over 2. You just have to be careful with the angles. Better yet, how about this? It's only pi over 2 if it's all 4 45s. It's the only time. Okay. You want to do the other 2 on that one? We're okay on that side. It'll flip over. So let's see. You had root 2 cosine, 5 cosine, 7 secant, and cosecant minus 2. Any one of those in particular you would like to check? There's no plus minuses here. That look like that. Which one? I'll get to it. You don't like factory, do you? What's that? Sure. So let's see. 7 secant x minus 7 is 0. So that means secant is 1. Secant is the reciprocal property of cosine. 1 has a reciprocal of. To get a cosine of 1 puts me on a quadrantal again. Is cosine your x or your y values? X. Where's x equal to 1? 0. And then since this is x is equal to 1 at 0, I have to get around to it again. Plus 2 pi n. 2 pi n be fine. Yep. Yeah, every once in a while you get one like that. You can write it either way because it means the same. This one was number 2. Yep, you can write 2 pi n if you want. That's fine. Absolutely. Absolutely. 11 then? Oh, I'm sorry. So mean. What? Actually, it's an infinite answer, isn't it? So on 11, you've got the root 2 cosine x sine x minus a cosine is 0. Okay. So in this one, again, you've got 2 terms. Since they're all not squared, what you want to do then is just look for your GCF. What do they have in common? Okay, they have x in common. Yes. What about the word in front of it? Cosine. Oh, no, it's cosine, not O-sine. It's cosine. There's a sound. And that's how you get it off. Okay. Now you have 2 parts instead equal to 0. I lost you, Jordan, right? Sure. Remember, all I'm doing here is think of it this way. Root 2 xy minus x. What do they have in common? They have an x. Factor it out. Nina. No, then you eliminate a solution. You do that, you eliminate a solution. That is it. That's something you guys did with just regular old factoring problems before. And I always yell that you don't do that. You've done this. You did this before when we had this. It was like 4x squared minus x equals 0. You guys did, oh, it's 4x squared x plus x. 4x is 1. And you did that. And I said, no! No! You're crazy! So don't do that. Yeah, right? Yeah. Make fun of me? Anyway, so you get cosine. What angle has a cosine of 0? And then what angle has a sine of 1 over root 2? Is it okay that I skipped that step? Yeah. Nothing wrong with it. All right, honestly, when was the last time you wrote a note? No, seriously, I mean. Oh. Anyway. So cosine being 0, that means your x coordinate 0. Where is x equal to 0? 90, 3 pi over 2. So this answer would be pi over 2 plus pi n. And then sine, this has to be a 45. And again, since there are it's just positive 1 over root 2, that means it's just going to be the 2 quadrants, so it's going to be a 2 pi n for both of them. So you have a pi over 4 plus 2 pi n and a 3 pi over 4 plus 2 pi n. Yes, sir. Oh well. So 11 was not a general, so then my other answer would have been 3 pi over 2. I didn't realize it wasn't a general solution. I just said, yes, and that's the difference. If you in the wording here, and I use the exact same wording. I'll say find the general solution of the equation, or solve the general solution of the equation, or solve the equation on the interval. So if it's solve general, there's an n in it, so you use n's.
Which one do you usually see?
I make it even. I make it even. I mean, obviously here they do more solve the equation on the interval because someone can be a little bit more tricky. It can be trickier, I guess. I don't know. Hey, Jordan. Yeah. Yes, ma'am. Yep. Hey, brother. It's also 0 at 3 pi over 2 because you're at 0, 1 up top, 0, negative 1 at the bottom. Yeah, I had forgotten that it was a general or an interval problem. For this one, yes. You have pi over 2, 3 pi over 2, pi over 4, 3 pi over 4. Sure. Remember which one was like that? I think that was one like the. Okay. Wasn't it? Was it number 5 one like that? Been there 6? All right. So I know we didn't have to do 6, but let's just quickly, we'll look at 6 because I want to talk about this one, and I've got a couple other problems I want to show you real quick. Just kind of where is this all going to, and what do we have to make sure we understand for tomorrow. In this case here, there's 2 terms. Really, the only thing I can do is just factor out a sine squared. Okay with that? So take out a sine squared. I'm left with 2 sine squared x minus 1. So I get what angle has a sine value of 0, because I take the square root of 0, it doesn't do anything. So this one is going to be sine squared is 0, so what angle? And then the other one, we get sine squared x is 1/2. But then I take the square root and I get plus minus 1 over root 2. So what angle has a sine of plus minus 1 over root 2? Be okay with that? And I skipped like 2 steps-ish in the middle of that. So sine being 0 means my y-coordinate is 0. Bless you. If my y-coordinate is 0, that means my x-coordinate had to be 1 or negative 1. So that occurs at 0 and pi. 0 and pi. Okay. 1 over root 2. 1 over root 2 happens to be which angle? It's a 45, isn't it? It's a 45, and it happens to be in all 4 quadrants. So if I'm all 4 quadrants of that, but this was a find all answer, it'd be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that gives me my 6 solutions. Okay. Hey, Jordan.
So the method gives you like
General?
this one.
The general, yeah. The general or interval?
The interval.
Yeah. All right. Interval, you leave everything. You don't touch anything. Okay. The interval means list everything. General means short width means put pi ends in it. Okay. Yes, ma'am. Yes, and I was just going to show, if this was a general solution problem, what I would do is this. 0 and pi are how far apart? They're pi. So this part would be 0 plus pi n. Okay. The other one was all 4 of my 45s, which meant it had to have been pi over 4 plus. And that would be my answer if it was general. But since it's not, I list them all out. Okay. That's the difference. Okay? If it's a general solution, yes. Yes. It's the only time it happens. Go back to the first page of this. I'm not like the 14.4 one. Flip it over, and I want to show you a little trick that they do sometimes on number 17. It's actually fairly simple to see how it works. In this case here, you have a sine and a cosine. It's kind of like solving an equation with an x and a y in it. Can you sign? Can you solve an equation with two different variables? No. You'd have to be able to rewrite one in terms of the other to get one variable. Yes, sir? No, because I want you to have all these problems to study off of. So one of the things that you're going to be able to do here, we'll probably do a little of this on Wednesday, is I want you to think of our unit circle. We've been given the radius more often than not on the unit circle itself at 1. You guys agree with me on that? We start at 1, 0, 1, 0, 0, 1, and so on. So if I give the radius a 1, that means that this is my going this way is x, and going this way is y. How can I write that in terms of Pythagorean theorem? Yeah. So x squared plus y squared is 1, or 1 squared. What's x in terms of trig, your x values are your cosine. What's your y's? Sine. So I can technically say then that this is cosine squared plus sine squared equals 1. Okay? Sorry, put my What's that? It can be, but that also means that if you have this, this is actually called a Pythagorean identity. If I want to get cosine by itself, or cosine squared by itself, what would I do? Sine squared. So I can say that cosine squared x equals 1 minus sine squared. Same idea that if I wanted to get sine squared by itself, that's 1 minus cosine squared. All by just manipulating that. Same basic idea of a squared plus b squared equals 1. If I want to write it in terms of a squared, a squared is 1 minus b squared, and so on and so on. Okay with that? What's wrong? I don't know. It's a substitution problem. You're substituting in something. Yeah, exactly. That's exactly right. Guys, I don't think you heard Nate. All you're doing is you're substituting in a word instead of a variable. Because here I've got cosine squared and a sine. I can't solve those at the same time, but if I put everything in terms of sine, I could. I know that I could rewrite cosine as 1 minus sine squared. To get 2, 1 minus sine squared. And what you do here, we're just rewriting a substitution step. Okay? You're rewriting a substitution step. Because now, what do I do with that 2? Yeah, you distribute. If I distribute that 2 across, you get 2 minus 2 sine squared plus a sine squared, or sine x, excuse me, minus 1 is 0. What's 2 minus 1? It's not a trick question. 1. So are you okay if I just get rid of that 2 and make that a plus? I didn't get rid of the negative, did I? Thanks. So now you're at a part where you can factor, aren't you? Sine squared, sine, plus 1. But we don't like to factor with the first term being negative, which means we want to move everything to the other side, or better yet, multiply everything by negative 1. What times what's negative 2, you add together to get negative 1. Negative 2 and 1. Negative 2 and 1, very good. And now we can split the middle term out. What times what's negative 2? You add together to get negative 1. Nope, because there's a 1 here. One of the things that I know that some people are doing already when they see all these sine squares and stuff, I have some kids that are just going right in, hey, long time no see. Hi. So what a lot of people are doing is this right here. They're just going, and they're just factoring it like that. They're using the U substitution just so there's less words, less letters and stuff. Because some people think it's cleaner. It doesn't matter. However you want to do it.
Wait, how'd you get the last part? Like,
What times what's negative 2 you add together to get negative
okay.
1?
Okay.
So, after you substitute sine,
Yeah. Yeah. Because then it just falls into the same way we've been factoring everything else. From this point down, it's all the same thing. Only thing was a little different since you have 2 terms. If it's cosine squared and a sine, I'm going to write everything in terms of the smaller value. If it was sine squared and a cosine, I would change everything to cosine. Because there's an identity that tells me how I can switch to squared. And then you just factor out your GCF like we were doing earlier. So you've got 2 sine x plus 1 and sine x minus 1 both equaling 0. A lot of people from this point, from this step, are able to write what angle has. If you want to, go for it. If you want to write it out the extra step before you do it, it's fine also. Basically, it's going to mean what angle has a sine value of negative 1/2. I had to subtract 1 divided by 2. What angle has a sine of 1? Because I had to add the 1. So 1/2. When I'm dealing with angles with the half for a sine, that means my opposite is the one. So that means I've added a what angle? 5 or 6. Now negative. Sine is negative in which 2 quadrants? 3 and 4. So here's negative 1 and 2. Negative 1 and 2. So that is pi over 6 down. So I'm at 7 pi over 6. 11 pi over 6. I think this was one of those problems that it was not on an interval, was it? Oh, it is interval. Okay. The list. And where do you get a sine value of 1? Where's your y value 1? Pi over 2. Okay. Yes, ma'am. If you have to write, and this is the only one that you'll see them like that. When you have cosine squared and a sine, that means you write everything in terms of sine. If you have sine squared and a cosine, you write everything in terms of cosine. It's like the idea when you are using units. If you have feet and inches, a lot of times it's easier to multiply by 12 than it is to divide by 12 to go up to use a larger of the 2. That's why we work the squared part to work our way down, right?
I thought you like stormed out or something. That's why I don't know. Okay.
Miss Nina,
So are you gonna do
we will, but not yet. There's some other Pythagorean identities that we're going to worry about. There's ones with cotangent, cosecant, and there's ones with secant and tangent. We probably won't even talk about those. We might talk a little bit about them on Wednesday. I'd like to do some very basic trig identity stuff on Wednesday into Thursday, but I don't want to give you too much before spring break because you just forget it anyway. One second, yeah, cool. No, because you're rewriting it in terms of sign. Yeah. And that's what we were saying. If you had a problem where it was a cosine squared, I'm sorry, if it was a sine squared plus it's a cosine x. See, David? I would rewrite that in terms of cosine. I say this is 1 minus cosine. I would do that. And then I can solve that. Okay. What do you mean? I can't rewrite cosine in terms of sine. I can only do it in terms of cosine squared, sine squared. The way the identities work. Okay? Because if you look at cosine, if you're just looking at regular boring cosine, a cosine value is your opposite, your adjacent, I can write, x over r. All right? That's the identity that we'll use. The other thing I wanted to talk about with you guys was, what's the difference between this one and when you have something that says evaluate? If you look at that older packet of fun that you guys have, yeah, the one with like 3 or 4 pages to it. No, I give you guys. You should still all have this, right? Oh crap. Yeah. Yeah. And I have some of them in here, I think, too. Now, the difference between if it says find the exact value of the expression or evaluate, that's when you had something like this. When you had that given to you, it says find the exact value or evaluate the function. That means you have to remember, where are you searching for your sign values as you're doing the problem. Whereas when we were solving equations, it didn't matter. If it's just this, you had to go for signs. Remember, you went between pi over 2 and negative pi over 2. If it was a cosine, and you had that, you went from 0 to pi. This is how you were solving them. Okay.
So it's like these were the ones where you wouldn't have to like list out all the answers.
Right. Yep. And then if it was a tangent, it was between non-inclusive pi over 2 and negative pi over 2. Go from 0 to pi. I wanted to make sure you guys saw that because it's been a while since you had done it. So if I'm looking at sine of, what angle has a sine of negative root 3 over 2? Well, if I'm a negative root 3 over 2, and I'm doing this whole evaluate, find the exact value, I have to move downward for the sine. So this is my opposite is the negative root 3. That means that's a 60. So this is negative 60 or negative pi over 3. Remember, that's when we did list it in terms of degrees and radians. Yes, ma'am. That's what I'm reminding you. You don't do negatives with equations. So if it just says that means you do the negatives if you need to. That makes sense? Yes, sir. Because that's what we learned. When you're finding an exact value, that's what we did. There were rules to it, and those were the yes. And cosine would just be an obtuse angle. Yes, Nick? Oh, I thought you had your hand up. Sure. The cosine? Yeah. Because if it was a cosine obtuse angle, that would have been, oh, it's just negative root 3 over. So for cosine to be negative, that means it had to go out this direction. So here's your negative root 3. So that means that your opposite was the 60. Excuse me, opposite was 1. So that means you had a 30 degree here. So that means that this was 150 or 5 over 6. That's what that would look like. Yeah, cosine was the one that you could get it obtuse. The other ones were always positive or negative. The other thing that was on here, like once you had a spin, like what is the sine of negative 17 pi over 3? Yeah, a couple of different things you can do. You can spin all day long, or you just count. 3 goes into 17 how many times? 5. 5 and 2/3 pi. So here's 5 and 2 pi over 3 is what you're looking at. It's negative, so you still start at 0. So you just count 1, 2, 3, 4, 5, and then 2/3. So if you go up 2/3, it means you are 1/3 up, and go from there. What's that? Feel better now? It's all off. Yeah, you can spin them around, do all that. Nina was asking, yes, ma'am. You're always bouncing off of the x-axis. If I move up 1/3, what's my angle? 60. So it's pi over 3. So I'm sorry, then sine of pi over 3 would be root 3 over 2. Yep. It always depends. That's the whole idea of the reference angle. Your reference angle, you're always bouncing off the x-axis. That's how we map it. Find the exact value. It's quite literally that's what it looks like. Okay. The other one, Nina was asking about this one earlier about positive and negative coterminal angles. Remember, all you're doing is just adding and subtracting 2 pi. One of the ones she had asked me about earlier was on your head of negative 11 pi over 6. Negative 11 pi over 6, whenever you're doing positive and negative coterminal angles, your first initial angle has to be within 1 revolution. If it's not, you got to back it into 1 revolution or move it forward into 1 revolution, depending if you're positive or negative. Is 11 pi over 6 within 1 revolution? Because a full revolution would be 12 pi over 6. Okay. So this one is within a revolution, so all I have to do is add pi over, and I have to take the negative 11. And then just do it real quick, because you don't have to get calculator right in this. Yes, sir. Sure. And if it's not within 1 revolution, yeah, I think Ian and I did this. We did negative 21. If you do negative 21, that's more than 2. It's more than 3, isn't it? Okay. So that one here, what I would do is I need to get it within negative. I get it less than negative 12 pi over 6. Okay. So what I do is I subtract my 12 pi over 6. I'm sorry, add the 12 pi over 6 to make it less negative. So if I add 12 to 21, we get what? Was it negative 9? So now I'm within, what's that? Yeah. So now that's within 1 revolution. There's my negative, and I add it one more time, and I get 3 pi over 6. And there's my positive. And then, just like I was saying, I would just simplify the fraction. and negative 3 pi over 2, and the other one would be just pi over 2. Okay? That's all you're doing. You get it within the one revolution. And play the game of working with your common denominators. It's the easiest way to do it. Okay? It's the easiest way to do it. Yes, ma'am. Yep. Yep. Yeah, then just do one more, because that's how you, I mean, it seems so cheesy to do it that way, but that's all it is. Yeah. I'll be here in the morning if you have questions. Your negative, as soon as you get within one revolution, there's your negative. Go beyond it, there's your positive. And it would work the same way if this was positive 21, I would be subtracting 12, and then I would subtract it again. Yes, ma'am. You have all of them. You have everything that I've done. I think I got a couple extra homework pieces. I don't know if I know. You want. Here's just on the bottom. No worries. We'll have it posted. We'll just. Yeah, I'm just going to do very Yeah, because. Oh, I'm sorry. Yes, this one was. I was.
So you're just gonna have to.
So if you know how a general solution, like this number that is